And hello, welcome to this video. So in this video, I'm going to continue where I left off. Of course, I'm unfortunately for you guys more familiar with VS Code, I've decided to do things in NeoVim. So do pardon me on that note. I'm just more comfortable with this, and this gives me a lot more real estate for the screens. Okay, but I'm just gonna start. Okay, I'm gonna start NeoVim. Okay, and let me make this like so. We'll pick up where we left off. Where were we? I can't even remember now. Cubic roots, vector multiplication. Yeah. So don't mind the bottom. I'm using screen key, which will sort of let you know what keys I'm pressing. So that yeah, if you wanted to see what I'm doing, you can. Okay. I'm gonna open tag bar on the right hand side. Of course, with NeoVim, there is some ability to use a mouse, but no, I'm not going to exactly do it that way. So I use HJKL to move up and down, but that's NeoVim, so that's that. Okay, now today let's talk about enums, the Rust option and result enums. Okay, the Rust option and result enums. So last video we were talking about the dot product. Okay, and we were making sure we had to make sure that that the vector lengths are identical, otherwise we have some sort of problem, right? So if the vector 1 and vector 2 are not identical, we will surely have a problem. Okay, so this is what I'm going to do. I'm going to copy and paste this. And maybe this thing is actually a bit distracting, right? Let me Okay, never mind. I'll leave it. Okay. I'm going to do the dot product, and I'm going to call this error handling. Okay, because one thing about this is that when you do dot products, you have to make sure these two vectors are exactly the same length. If they're not the same length, then you're going to have a problem. Okay, so let me just do my usual cargo watch dash x test dash 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 no capture. Okay, and I'm going to speed this part up. Okay, now obviously this fails. Why? It says what? Dot product error handling. Panicked. Index out of bounds. Length is 3, but index is 3. So basically, the problem with having two different vectors is that, hey, we'll have this error in the dot product. What's this error? Okay, the error is that when I use this vector 3, for example, okay, just ignore the earlier, actually, even the earlier parts, yeah, that's important. When I take vector 1 and I take the length, I realize there are 4 elements. Okay, 4 elements in vector 1. Vector 1 is right here. This is vector 1, it has 4 elements. Excuse me, it has 4 elements, and now I want to use it with do a dot product with vector 2, which has 3 elements. Now this issue comes when I am actually trying to multiply this 124.3, which is element number 4. Okay, and remember we start at index 0, so this is actually index number 3. The 4th element is index number 3. Now I have I'm trying to access the 4th element within vector 2. Okay, vector 2 is right here, and I'm trying to have index number 3, I'm trying to find the 4th element within this vector. However, this is not going to happen because it says what? Index is out of bounds. Okay, index is out of bounds. So these are common errors that can happen in making a simple dot product code. So there are many methods of error handling. So one of the ways is where if the lengths are not equal, I do not return a value. Okay, I do not return a value. How do I do that? Okay, so one of the ways is to do this, to use the option enum. Okay, option enum, and I'll wrap this in an option. Okay, and then over here I'll just put, okay, I'll just wrap this in an option. So yes, we have option enums, okay, that we can use, and this is one way to handle error. But before I go to option enums, I have it'll be kind of a little bit rushed for me to just throw the option enum there without introducing what enums are. Okay, what are enums in the first place? Okay, so I did that in the last few videos, and I kind of promised you that I will talk a little bit more about options, option enums and results. All of these things are important to discuss because you will see a lot of them in Rust code. Yeah, so let's deal with basics of enums first before we talk about options, and that will help at least give us some basis for what we are doing here. So I'm going to write another test. I'll just have this call this an enum demo. Okay, here's our enum demo right here. Okay, here's our enum demo. What it's here to demonstrate obviously is an enum. So let's make a new enum. How do we make enums? Okay, this is the syntax: pub enum my enum. Okay, or let's see. So the closest way I can sort of okay, so an enum, well, let's do something like this, eh? So an enum is basically like a drop-down menu. Okay, a drop-down menu, and you can so-called select a value from this so-called drop-down menu. So let's say we have an enum called engineering grades, because I know as a student, grades are important. So what are the possible grades that you can have in engineering exams or exams in general? You can have A, B, C, D, E, and F. Okay, maybe these are the grades that you can find. So this will be an enum. Okay, this is an enum. Your grade can be represented as an enum. Okay, and all of these things here are what we call variants of the enum. Okay, so an enum can be as such. This is what an enum is, and okay, and how do you use it? Okay, so let's do this in the enum demo. Let my engineering grade equals to engineering grades, and I'll put a B down here. This is how you use enum. Okay, and what can I do with that? I can actually just do a debug my engineering grade. Okay, this is what you can do. Unfortunately, here the compiler says that the engineering grades, or the linter, it says engineering grades doesn't implement debug. Okay, so you can just follow what the compiler says. Just use the derived debug macro. Okay, so similar to this test macro or test attribute, whatever you call it. I'll just put the debug the debug macro right here, and that will allow us to do the debug. Okay, so here is what the engineering grades look like. If you debug this engineering grade, you will see that B is actually printed out. Okay, my engineering grade is a B. So these enums are useful for this. Okay, so it will allow you to sort of select a value from many of these values. Now, of course, enums themselves, they are not just used like that. Okay. I mean, no, let me put it this way. Grades themselves, they don't only have a letter grade. Sometimes you also want to know what score you actually put, right? What score you actually have, right? So how do you do this? Let's say on a score of 0 to 100, okay? Okay, let's say on a scale of 0 to 100, your 75% and above is an A. Okay, 75% and above is an A. So you want to sort of see your actual score here, right? So if you want to see your actual score here, you can actually let's say for grade A, okay, I have a score of 60, no, I have a score of 75 and above. Okay, I will need to store a floating point number in the A variant. Okay, for example, if I want to see the score. If my engineering grade is a B, I also want to do the same thing. In fact, for any of these grades, I want to do the same thing. I want to have a float 64 encapsulated in there. Right? So let's say my score is 67 points, 67.0. I can actually put it into the V variant like so. That means to say, whenever I have B, I have actually a score that is embedded within here. I have another piece of data embedded within this enum. Okay, and you can see that when I debug this out, my engineering grade is B, and within B there is a floating point number called 67. Okay, so the thing is, this is what you can do with enums. So enums is like basically a drop-down menu where you can select a variant. What we call these variants, and in each of these variants we can store as many pieces of data as we want. So for example, here we have a piece of F64. Okay, an F64. A floating point value can be stored inside there. So let's say we have a marker. Let's say, yeah, what can we do with enums? Yeah, let's say first thing first, let's in the context of grading, we can convert those grades into an enum variant. Okay, so how do we do that? Okay, we can actually use a function. We can actually use a function to help us convert grade to enum, or convert score to grade. So this is a very simple function just to demonstrate how enums can be used or constructed. So I have the score, which is a F64 value. And then what I want to return is an engineering grade. So this is how you can actually use enums within a function. Okay, so what happens if score is more than 75? Okay, I'm not going to care whether it's 100 over 100. I'll just say if it's more than 75. Okay, then what happens? Okay, I will return engineering grades. Okay, I'll give you an A score, with this score value, right? Okay, if score is more than 75, okay, I return an engineering grade. Okay, this will be an A score. Okay, so let's say B is 65 and above. I can use the else if score more than 65. I'll give you a B score. Okay. let's say uh, a C is 60 to 65. Okay, a C is 60 to 65, more or less. Then you'll get a C score. And so on and so forth. Excuse me. Okay, I'm gonna do the D score, E score, and F score. Okay, so if your score is not more than 50, you have an F. So, let's see. So let's say let my score equals to 74.0, and this will be a float 64. And let my engineering grade equals to convert score to grade, yeah? Convert score to grade of my score. Okay. And let me see whether my Rust analyzer is working. It should be. Yeah, that's my LSP. Oh wait, yeah, it is working, of course. It should be working. Okay, it's not working so nicely now, but let me check. Okay, so this is how you can construct an enum or such. This is one example of how you can construct an enum. Let's do the debug of my engineering grade, and this time we should expect an A. We should expect an A with a 74, or rather B. Excuse me. We are not at A yet. 74 is less than 75, so this is a B score. Okay, that's hard. Okay, let's say we have 84. We should get an A score this time. So you can see that this is what enum can do. Enum is basically like a drop-down menu that enables us to store data in a certain way. It is still pretty abstract for now, but hopefully this example makes it slightly less abstract. Okay, so this is what enum can do. Okay, and what can you do with enums? Okay, you will see very often that depending on the enum you get, you can actually do certain things with this. So for example, if let's say you get A, you can print a message saying you are on the dean's list. Okay, you are on the dean's list. If you get an F, we say please work harder or something like that. I don't know. You need to redo your course. That's very painful to hear. I'm sorry if you went through that before, but yeah, this is one example of what you can do with enums. Okay, so let's say we have something called print special message based on your enum. Okay, if you get A, then we print well done. Okay, well done. Okay, so how do we do that? We can actually use the match expression. Okay, match expression basically checks for what the value of the enum is. Okay, for example, if it's an A, you can print a certain message. If it's an F, you can print a certain message. Okay, so this is what we call a match expression. Okay, match my engineering grade. Oh, come on. It's not working. Haha, never mind. I don't know why it's not working right now, but okay. So match expressions are as such. So let's say if you have an A, you want to print the well done statement, right? So how do you express this out? Okay. So let's say you have the engineering grades and then you have an A. This is how the match expression looks like. You have engineering grades A. If it happens to be an A, okay, and then the A of course has to have some certain score, right? Because we said that we mentioned over here that A must have some kind of score or F64 value, and this happens to be the score. So this is what you can do. Okay, if it happens to be an A, you can actually print well done. Well done. Okay, so I'll do print line. Well done. You are on the dean's list. Something like that. Okay. And then actually I don't want to bother printing out the score. So I'll just leave it as that. Okay. The nice thing about before I go there, what is the error now? I am not able to actually compile this code. Why? Because it says that Rust doesn't know what you want to do for B, C, and D. All of these have to be covered. Okay, whenever you design an enum, you have to specify what you want to do when this match expression comes out. So anytime you use this match expression, you have to tell Rust compiler, you have to tell the Rust compiler what you want to do in all of these cases. So B, C, D, E, F, what do you want to do? So we already know what we want to do with the F variant. Okay, what we want to do with the F variant is say like maybe you need to repeat the course, right? You need to repeat the course. Ooh, that's painful to hear, but yeah, this is what you need to do. Okay, I have to change this to F. Okay, and the way to separate out the two cases is with the use of this comma right here. You can see this comma right here that my cursor is on. This is what you need to do to separate the cases. So again, when you use this match expression, you need to say, okay, the match expression allows you to execute certain lines of code depending on what your enum is. So for example, if your enum is at A, you can actually print out, well done, good job, you're on the dean's list. If your enums an F, means you did very badly on this engineering grade, then you need to execute a different line of code. So this one says you need to repeat the course. Yeah. So for the grades D, E, B, C, D, and E, I don't really care what I want. I don't really care to print anything out. I'm not going to print anything special. So what do we do? Okay, you can do this manually, which is not the best way, but that's for the sake of explanation, I'm going to do it manually. So if there's a B score, if you scored a B, I'm not going to do anything. Okay, to don't do anything, you just put these brackets like so. This is as good as returning nothing. Okay, so I like to put these brackets there just to say yes, I'm doing nothing. I'm literally doing nothing. Okay, I'm gonna save this, and then it says you still need to handle all the other cases, B, C, D, and E. So I'm gonna paste this 3 times. I'm gonna replace this with C, replace this with D, replace this with E. Okay, and now this thing should work. And then since I got an A, I see this thing called well done, you're on the dean's list. Okay, and then of course I can actually do it like so. I'll match the engineering grade when I score. Oops. I'll match my engineering grade when I score this, when I score my B. Okay, when I score my B. Okay. Okay, hold on. I'm getting B, C, D, and E. Okay. Okay. Oops. Okay, there's a typo there. Okay, never mind. Let me copy and paste this, and I'll put this here. If I happen to score a B, if I happen to score a B, then it should not print anything out, right? So the first score here is what I scored a B, and then I should not be printing anything out. So you can see when I score a B and I put this match expression here, it didn't say anything. Okay, so match expressions help you to execute certain lines of code depending on what your enum is. All right, so this is the very verbose way. This is the very verbose way of writing all of this out. And always try to put a comma down here. All right, put a comma down here so that you will tell the Rust compiler that, hey, these are different enums. Okay, but as you saw just now, you don't really need that, but just out of habit, do that. Really do that. Okay, because if you don't have those curly braces, you will need the comma. So my practice is just to always put the comma there. Okay, so enums they have this match statement, and that's one good thing about it. Match statements allow you to execute certain lines of code depending on what your what variant your enum actually is. Okay, so for the A and F variant, I want to print out certain lines of code. For anything else, I do not want to. Okay. So now how one thing is, how do we make this this thing here a little bit more concise, right? How do we make this thing here a little bit more concise? Okay, the way to do it is what we call a wildcard. So we saw here that for B, C, D, and E, B, C, D, and E, B, C, D, and E, the scores B, C, D, and E, so I say this too many times, but yeah, for these scores, I do not want to do anything, right? So if I don't want to do anything for these scores, I don't have to type it up manually. I can just simply do this. I can use this wildcard. This wildcard is an underscore, and it basically says, what this code is saying is that for A and F, I want to print out these lines of code, but if the score happens to be anything else, I don't care what it is, then I want to do nothing. So to express that in a very shorthand form, this is what you can do. Okay, for this underscore is a wildcard. So for any of the cases that don't match these two, A and F, for any other cases, this is a piece of code to execute. Okay, this code is basically doing nothing because I showed that this bracket before. I mentioned that this is doing nothing. Okay, all right. For any score not A and F, do nothing. Okay, so for any score not A and F, do nothing. Now this is what these lines here are. This is saying. So this is a very shorthand form for doing all of this, in a very manual manner. You may not want to do it in this manner, but yeah, this is what this line of code is doing. And you'll see this expression pretty often in Rust code. So these are the basics of how you deal with enums. So enums are basically like a drop-down menu. They are like a drop-down menu, and you can store pieces of data in the enum using these brackets. Okay, and the useful thing about enums is that you can use this match expression to say that if your variant happens to be, your enum variant happens to be certain things like A or F, you can execute certain pieces of code. Okay, so this is just a very simple demo for enums. Okay, in fact, I want to put everything in here. Can I put this in here? I like to put everything in here. I don't want it to leak out into my let's see. Oh, yeah, it works okay. Yeah, I want to put everything here because I don't want my code to leak out, so to speak. Okay, so this is the enum demo. Very very compact enum demo. Okay. So okay, you want I think yeah, that's it for the basics of enums. And I actually want to sort of get rid of these warnings. Okay, it says here unused variable score. It says here unused variable is score. So how can you deal with these warnings? You just put an underscore in the front to say that, yeah, I don't want to actually bother with it. I don't want to bother using it. Okay, that's one way of doing things. Okay, second way of doing things is that just replace the whole thing by underscore. Okay, this is telling the Rust compiler that says I don't even want to bother using whatever value is in here. So that's how you make these warnings disappear. Okay, so this is it for the enum demo. Now what does this have to do with the option enum? Okay, so in the option is basically one type of enum. You can see here, pub enum option of a certain type. Okay, this is what we call a generic type. Okay, don't worry about it. Most important thing is that there are two variants of this enum. One is called none, one is called some. Okay, the none enum variant is actually used to say this enum doesn't contain any data. It's a null value, so to speak. It's a null value. Okay, whereas the sum variant of this option enum, this is the way to communicate that, hey, we have a variant called sum. Okay, and there is some data around. That's what you're trying to communicate with these two enum variants. And as with all enums, you can use a match statement on this option. Okay, so that's how you can actually express over here that, let's say this that there is something wrong. Okay, so I'm going to use the option enum right here as the return type. Okay, and if the lengths are not identical, okay, then we will return nothing. Okay, so let's do this. Let vec1 length equals to vector1. Okay, never mind. Let me do this even shorter. If vec1 dot length is not equals to vec2 dot length, okay, execute this certain line of codes. Okay, return none. Okay, otherwise, if everything's okay, we return the sum variant. Remember just now, when we were doing the engineering grades here, okay, how you actually return these grades? How you actually let's see, where did I put the function? Yeah, convert score to grade. Okay, I have to return the enum, and I have to put a value inside. So this is what we are doing for the option. Okay, we are doing for the option here. We are using a sum variant. The more full version of writing it is like this, option sum. However, what you will see in Rust code more is that you will just see this more short-handed version here. Okay, it makes the code a little bit easier to read. Okay, now what we need to do, okay, is to actually get the match statement out. Okay, we need to actually use the match statement to actually get the value from the sum variant out. Okay, remember we were talking about match statements a little bit earlier here. So we need to use a match statement to get the variant out. Okay, so this is how you do it. Match scalar. Okay, match scalar. Let this is how you do it. Let the value equals to match scalar. I'm going to change this to value. Okay. Okay. Okay, so let's see. No, I cannot. So what are the cases here? Sum, if I have sum of something, okay, I have some value. Yeah, that's over here. That's if this is the case where everything works out okay. Okay, then my data will be wrapped up in the sum variant. Okay, now my data will be wrapped up in the sum variant. So what I want to do is just to extract this value out. If it's a none, then I'm not going to do anything. Okay. Make sure, forgot my semicolon here. Okay, and now it's complaining about something else, that my match statements have a incompatible data type. Ah, yes. Okay, so this is saying, oh yeah, I cannot just do I cannot just do nothing. It's expecting a F64 type, but I found nothing. So what can we do in this case? Well, what we can do something called a panic to say that there is some sort of error, and that will just cause the code to shut down if there is this error. Okay, and let's do the same. Let me see. Let's do the same for all these other codes. Okay. And this code should sort of work now. Okay, it says this trait relative option is not implemented for float. And okay, let me do this. This should be a float 64. Oh yeah. Oops, I mistook it. I mean, just now the code actually worked. I was looking at older error messages. Okay, so this is the result of the code now. Okay. So no, yeah, this is what happens now. So what actually happens here? The vector multiplication, okay, this thing is actually they say panic at explicit panic. Okay, basically what it's saying here, what's actually going on here. So you see that there are two vectors of unequal lengths. There are two vectors of unequal lengths, and I try to dot product them. But what does this dot product code do? Okay. Yeah, that doesn't go there. Okay, never mind. What this dot product does is that if the vector 1 length and the vector 2 length are not equal, I will have a none value. Okay, a none enum that comes out. Okay, if I have this none value, that comes out in this scalar, then remember this batch of code here, this match statement, it asks us to panic under the none variant, and that should be the way. So that's how you sort of deal with option enums. Okay, this is the option enum. Okay, of course, you won't see option enums as much as what we call the result enum, but we'll deal with that later. Okay, so is that a better way of having this match statement? And answer is yes. we don't see this match statement used for the option a lot because there's a very much more compact way of writing all of this. Okay, this is called the unwrap. Okay, we did the unwrap before, if you recall, in the last video or two. Okay, we use this unwrap function. What does the unwrap function do? Okay, what does the unwrap function do? Okay, unwrap function, basically it does the same thing as before. Okay, it gets the value if this is a sum variant. If there's a num variant, you just panic. That's what unwrap does. Okay, you can take a look here. Unwrap, okay, returns the contain sum value, consuming the self value. Okay, so basically, if the option is none, okay, I will panic. Okay, panic. So this function will panic if the self value equals to none. So basically, self is this scalar. If the scalar has a sum value, you extract the value out. If it's a none value, you just panic. That's what unwrap does for you. That's the explanation. Okay, so hopefully this sort of lets you get a little bit more insight as to what an enum is and how it can be used in this case. All right. So this is what you see very, very often in Rust code. You use a lot of enums. One of those enums is option, which we have discussed. Okay. And then, of course, we have the other enum, which is called result. But that one we'll deal with later. Okay. So I'll stop the video for now because it's a long video. So I'll see you next time.